Today we begin an exciting chapter, chapter 5, linear functions, and want to start out looking at basically what is a linear function. So if you take that word linear, you have a whole bunch of words inside that word linear. If you look, you can see ear and near and in and I and a, and if you're a pirate, R. But the one that really matters here is line. So let me get rid of that. We have line. So if you have something that's a linear function, the linear part means it has to be a line. So this here, linear, is that it's a line. So straight, never ending, that sort of thing. The function, for that, that's going to be something I think new, and that is that each x has only one y value. Actually, in hindsight, I think we did that in chapter 4, so maybe that's not new, but each x has only one y value. Now, but we're looking at it with graphs, and I'm going to jump ahead because it makes it a little bit easier, but first we'll look at these 5 different examples and say, are they linear? So example number 1, it's a straight line kind of going up on an angle, so I'm going to put in an L for linear. You'll notice I have like the L and the F underlined. That way we don't have to write everything, write the whole word each time. So example 1 is linear. Example 2 is curved, so it's not straight, so then it's not going to be linear, so I'm going to leave that blank. Example 3, same sort of thing, that because it's a curve, it's not a straight line, then you know that it's not linear as well. Example 4 is nice straight up and down, so that's going to be linear, so I'll put an L underneath it. And example 5, a horizontal line, nice and straight, so that gets a L for linear as well. So, now for function, each x has only one y. So I'm going to digress a little bit. Well, actually this is on track, so maybe it's not digressing, but I don't know if I'd bother writing this, but if you have like a normal graph, if you have some points that don't work, maybe let's say I have the point here and I'm just going to make up that it's like a 3, 2, and maybe like a 3, negative 3. So if we have a line that goes through those 2 points, or a curve or something like that, or we just have those 2 points, they're not a function, because in those 3 is paired with 2 and 3 is paired with negative 3. So each x can only be paired with one y value for it to be a function. So that's not a function. Well, if you look at how those 2 lines are related to each other, they're going to be in this vertical line state. You know that the same x value is going to give you a nice straight up and down line. So when we look at a graph, we could just say, well, is there any place on the graph where you have 2 points that are in a vertical line? So you could, I don't think I'd mess up my graphs by doing this, but you could look at it kind of visually as though if you put a whole bunch of vertical lines through the graph, if any one of those touches it in more than one spot, it's not a function. So this first one here, I could do a bunch of vertical lines anywhere on that line. None of them are ever going to touch it. So then we know that this one here is also going to be a function. So it's L and it's F. So F will be in red. Example 2, again, I don't think I'd actually draw in the lines, but if you have a whole bunch of vertical lines in this second example, no single one is going to hit it more than once, so that also will be an F for a function. Example 3, though, pretty much all vertical lines except for one that would hit it just here at the end would maybe just graze it and get 1 point, but all the other ones are going to hit it in more than one spot. So this one is not a function. You could just not put the F by it, but I want to kind of write this out just to kind of draw emphasis to that thing where it hits it in 2 different spots. Example 4, function, not a function. Well, if we do a vertical line, that vertical line would be right on top of it, and it hits it in an infinite number of spots. It hits everything, so that's also not a function. So not a function for that one. Maybe I'll write not F. And our last one, example 5, a horizontal line. You could do a whole bunch of verticals. No single one is going to hit it more than once. So we know then that example 5 is a function. So L and F. So that's the first part of the section, kind of the linear and the functions. Now we will move on. If we want to look and say, our point's going to be linear. So it's not this vertical line. We need to back up to where we were talking about linear. And if we look at the ones that were linear, so we have this example 1 here, it has the same steepness everywhere on the line. Example 4, yep, same steepness, it's kind of straight up and down. I don't know if you can call that a steepness, but a horizontal line has a steepness of 0. So a straight line has to have the same steepness, but steepness was slope. So then we could say for this here, if it's linear, it's going to have a constant slope. And slope, I've said, I like thinking of it as rise over run. That helps a lot of people. So I'm going to say same rise over run. And we'll get into the actual slope equation, which does make it a lot nicer in all honesty. But until we get to that point, if we wanted to look at, well, how much does it rise? The rise is going to be the change in the y values. So here, the change in y is 3. And the run, the horizontal change, the side-to-side change, is going to be a 1. So the slope then would be 3 over 1, or 3. So between these first 2 points, we have a slope of 3. If that slope is always 3, then it's going to be linear. So here I go from 6 to 9 is another rise of 3. 2 to 3 is another run of 1. So I get the same 3 over 1. So the slope is 3, so it's going to work out. The next one, we'll jump ahead here. So my rise is 3, my run is 1. So I have a slope of 3, 3 over 1 there. Now here I have a rise of 5 and still a change of 1. So my 5 over 1 gives me now a slope of 5. And we could keep going, figure out what the slope is between those last 2 points, but already we know it's not going to be a line. Because at one point it has a steepness of 3, it's going up a certain amount, and then it has a steepness of 5, it juts up more quickly. So my first one, I guess I didn't really answer it, so this one here is linear. And the one on the right is not linear. That's because the 3 does not equal 5, and those are going to be the slopes. So if you get some data tables, go through, figure out the slope at some different points, and you're golden. So, all right. The last thing, and this I'm not really sure what the best way to teach it is, so I'm going to try 2 different ways. Some works better than others for different people. And I'll go back and do the writing thing there at the top probably. So could the equation be one of these 2 forms? So one way to look at it is the 2 most popular line equations is ax plus by equals c, and a, b, and c are numbers. So in other words, when we talk about something like that, an example would be maybe like a 5x minus 3y equals 17, or something like that. So we have a number in here, so we have a number in front of x, that's 5 is my a value. B, it's plus b times y, so this is a negative 3 for b, because this is kind of like saying plus a negative 3y. So b is negative 3 and c is 17. So that would fit. Probably the most popular line equation, though, is y equals mx plus b. And we're going to use that a lot more this chapter. That's going to be real popular. But for that, m and b equal numbers, or are numbers. So we have that there. M and b are numbers. For those, you don't always get equations that are nicely in, well, maybe I should do an example. Hit an example quick. So y equals 2x plus 7, something like that. But for those to work, you might have to, so now I'm going to fill in the thing up above, move things around. In other words, we might get something like, I didn't really plan for this, so this is off the cuff a little bit, but if we have y plus 2 equals 3x, that doesn't fit either one of those equations. But we could try to take and change it into this, or change it into that. We could do either one. If we wanted to change it into that top one, we could take and subtract y and put it over here, and we'd have 3x minus y equals 2. So 3x minus 1y equals 2. So it would fit in that equation. We could also subtract 2 from both sides, and then we'd have y by itself equals 3x minus 2. So that fits the y equals something times x, and then plus a negative 2 or minus 2. So then this here would also be linear. So be a little careful if it doesn't look exactly like it. You have to say, well, could I try to change it into one of those? So some people will grasp onto that. They know it. They love it. If you don't like that, here's another way that you could look at these. So here's kind of a couple rules. So linear unless. You really could kind of fit it into 2 rules. I'm going to say you have a number divided by a variable. So if you ever have like a 5 over x, it's not going to be linear. So y equals 5 over x, y equals 5 over x plus 7, 5 over x plus y equals 9. If you ever get a 5 over x, or a number divided by x, or a number divided by y, it's not going to be linear. The other thing is you can't have a variable times a variable. So no variable times a variable. Squeeze that in there. So the example for that then would be if you have like y equals x squared, because x squared is x times x. That's not going to be linear, that's going to give you a parabola. We'll study those more later on this year. Or another example would be if you have xy equals 5. Xy equals 5 is going to be a hyperbola. You'll get that in Algebra 2. But you could see that also kind of relates to that first example, because if I were to divide both sides by x, I don't think I'd mess up my notes with this, but I get a y equals 5 over x, which you'll notice is my exact same example as up there. So I'm going to get rid of some of these chicken scratchings. So either way, I'd say pick a way that you can memorize, that you can use, pick a way that makes sense to you. And that's all I have for this section. We have some learning targets there at the bottom and homework assignment. Let me know if you have questions. Thanks, guys.